So, good afternoon, guys. My name is Sharat Chandra. You might be already having some kind of acquaintance with me regarding the student activities. So, I will be your instructor for the course on analog electronics. Okay. So, before we proceed into any kind of introduction to analog electronics, so I want you people to involve in some kind of interaction with me. So, what I have done is I have created a small kind of interactive session for you. So I'll be giving you a link. So all you need to do is you have to open that link and then enter whatever that comes to your mind. Okay. So so you can browse your chat box. In the chat box, I'm leaving a link. Did you get the link? Just check.
No, sir.
Sir,
Just a minute. I think you got this link. I could
yes, sir.
able to right. Okay, I'll
Voting
be
Mentimeter like
yeah,
chatbot.
yeah. It's a small voting is there for you. So all you need to do is you need to open that slide. I will be showing you on the screen also. Okay. So can you see my screen?
Yes,
Yes,
sir.
sir.
Yes, right. So I think in the screen you can see one question. What's the question that you are reading on the screen?
What comes to your mind when you think about analog electronics?
Right? The same thing. So you mute yourself and answer to this question. So you are given a link, you have to open that link and you can post your answers over there. Okay. I'll start. I will open this one. Mm, okay. I think 8 people have answered already. So you can give multiple answers also if you want. Okay. Multiple times you can input your answer. So I'm getting some random answers like signals, circuits, variable signals, continuous signal. signals representation based on signals, time-based devices, communication, continuously variable, circuit signals, wall clock. Somebody has even written that I don't have any idea. Logarithms, transfer signals. Okay. So I need all the 80 people who are already in the session. They should answer. So I will get to know what's there in your mind. Amplifier, integrated circuits, core subject, nothing comes to my mind. Okay, fine. I'll close the voting. I think already crossed the 82. Okay, now it is closed. So from this word cloud, I could see that most of you think about analog electronics as something to deal with signals, circuits, variable signals, digital electronics, communication, and even few of them have told that nothing comes to their mind. So no problem. So initially, may not be having any idea regarding the subject. So I'm going to introduce the subject today. Okay. So analog electronics is one subject and the digital electronics another subject you have in this semester. So digital electronics basically deals with zeros and ones. So you'll be learning about some Karnaugh maps and all those things. Whereas in the subject called analog electronics, you'll be learning about basic electronic devices such as diodes, your PN junction diode, your Zener diodes, and the applications you'll be learning. Later on, you'll be learning about transistor, your bipolar junction transistor, BJT, how it operates, uh, what are these applications, how you're going to use the BJT as an amplifier, and then you'll be seeing, learning about JFET. So JFET is junction field effect transistor. So basically, you are going to learn in this subject about devices that you are physically able to see, like a transistor or a diode, where both the input and output are basically analog signals. So you're directly giving a voltage signal. You're not giving zeros or ones. You're not giving pulses, and you're getting some similarly analog signal output. So for your seniors, this subject used to be a hello. Can you hear me? I just want to know whether I'm audible or not.
Yes, sir. Yes, sir.
Yes,
Yes, sir.
right.
Sir.
Okay. For your seniors, this is in the 2-1, and the subject used to be known as electronic device and circuits. So I think even your timetable it is given as EDC, electronic device and circuits. So in the A1 regulation, it used to be only regarding these basic electronic devices. So okay, they used to deal in depth about this basic electronic device and circuits. And then later in the 5th semester, that is current 3-1 semester, they are going to learn about operation amplifiers, timers, VCOs, different kinds of signal generators and all those things. However, coming to the A2 regulation, what we have done is we have combined both these subjects. So what your seniors are learning as two different subjects, EDC and you have linear integrated circuits. So both these things you will be combining together and you will be learning in a single subject. Okay, so I'll be showing you the syllabus. Just a minute. I think some. You can mute yourself if you are in a disturbed environment. You can mute yourself. Otherwise, I will be forced to mute you. Okay. So this is your course home page. Okay. So this course objective is to make you learn the working of diodes and transistors and the applications, understand the working of operational amplifiers. This operational amplifier is a little different from your traditional amplifiers made by transistors. And you should know the nonlinear applications of op-amps, simplified timers, and VCOs. And you will be learning about some waveform generators and signal generators, voltage regulators, and so on. And you should be able to design some analog electronic circuits based upon the application. And at the end of this course, you should be able to recall the fundamental concepts of electronic devices such as diodes and transistors, describe the principle of operation of JFET on the operational amplifier, outline the working operation of simplified timer and voltage regulators, explain the procedure for clipping and clamping circuits, summarize applications of op-amps, and just reading out what's already you can see in the screen. I'll explain them in detail, explain about different waveform generators, and some kind of application outcome is also written. Apply the inside fundamentals of electronic components to solve real world problems in field of engineering. So when you come to your department, electrical and electronics engineering, only half of the portion is your electrical. The remaining half is your electronics. And this modern world is entirely you are equipped with these electronic devices. So beginning with your mobiles in your hand or your TV that you are seeing, so everything is based upon some kind of electronic circuits, your PCBs. So your PCB has a lot of millions of transistors inside it. Okay. So coming to the syllabus part, I'll be showing you. So in this course is only a fundamental course in which I will be introducing you those very basic components such as diodes in the first unit. So can you see it? Can you see my screen? I'll be zooming it for you. Are you able to see the screen? Is my screen visible?
Yes, sir.
Right.
Yes, sir.
Okay. In the first unit, you will be dealing with the PN junction diode. You will be learning about the structure, operation. You'll be learning about the diode equation. So diode equation, I mean to say that current equation. And then you have this diode equation. You have I is equal to I naught in t power eta V by Vt. That is very famous equation that you will be deriving it if time permits. And then you will be learning about the VA characteristics curve. I think most of you already know about basic VA characteristics of a PN junction diode that you might have already learned about forward bias and reverse bias. That again we are going to see in this unit. Later on, we'll be seeing about the applications of PN junction diode as a half-wave rectifier and full-wave rectifier. In the full-wave rectifier, we are dealing with two different configurations: center tapped transformer configuration and a bridge type configuration. And then we'll be dealing with the special diode called Zener diode. I think most of you are already know that Zener diode acts as a voltage regulator, right? So we'll be dealing with the structure, operation, characteristics. You'll be learning about this applications of this diode in the clipping and clamping circuits. So clipping circuit means that if we have a sinusoidal signal in which from which we want to obtain a different type of signal. For example, you want to get a trapezoidal signal. What you will do? Uh, so I can say that if you have a simple waveform, sinusoidal waveform, you want to cut it into pieces such that you get a different waveform. So such kind of cutting this waveform using these diodes, I can say in the layman's terms, as a clipping circuit. A circuit which is used to trim down or lay off some of the portions of your sinusoidal signal in order to obtain a different signal. It will not be your sinusoidal signal. It will be a non-sinusoidal signal. It can be a trapezoidal signal. It can be a triangular signal. Any other signal it can be, depending upon where we are applying this clipping. Okay, and then clamping. So clamp means to fix the voltage. So we are clamping the voltage signal to either, let us say initially the signal magnitude is 5 volts. You want to clamp it to 10 volts, or you want to reduce it to 2 volts. That we can say that clamping. Clamping means to fix the magnitude. Okay. So here mostly we will be only shifting this, we will be shifting the magnitude of your signal. Okay, that is your first unit. In the second unit, you will be dealing about transistor. Diode is a two-terminal device, whereas transistor is a three-terminal device. So you have bipolar junction transistor. We're learning about operation and what are different current components. You have both majority current components, you have minority current components. You'll be dealing about different types of currents like diffusion current, and also you have current due to your conductivity. So because of application of your potential, there will be a current. So we will be seeing about different current components, and then we will be seeing the application of transistor as an amplifier. So by the word amplifier, I mean to say that we are going to increase the signal. Either we are going to increase the voltage magnitude, or we are going to increase the current magnitude. So we'll be seeing about different configurations of the transistors, and we'll be seeing the amplification properties of this configuration. So we have three different configurations. Basically, we have common base configuration, common collector configuration, and then common emitter configuration. So when you have three terminals for a transistor, we'll keep one terminal as a common terminal to both the input port and the output port. So you know that in a two-port network, you have two terminals for each port, right? So on the input port, you have two terminals, and the output port, you have two terminals. However, because transistors having three terminals, we'll be keeping one terminal as common to both input and output port. Okay, so whichever terminal becomes the common terminal, we'll name the configuration based upon that terminal. So in the common base configuration, your base terminal will be common to both input port and the output port. In CC is a common collector configuration. The collector terminal will be your common to both input and output port. Similarly, we have common emitter configuration. We'll be learning about the characteristics, and then we'll be going for small signal equivalent circuits. So in the small signal equivalent circuits, what we are going to do is we are considering this transistor circuits as a linearized circuits. We'll be learning about this H parameters and all those things. So already you might be learning about this H parameters in your circuit analysis part. Okay, is the circuit analysis subject started for you in the first year, or you are going to study in this third semester itself? Please let me know. Please unmute and answer.
This semester, sir.
Okay. In the circuit analysis, you'll be learning about something called two-port networks. So basically, so I can say that two port as nothing but a black box in which you have two input terminals, you have two output terminals. You may not be knowing what is actually inside the that black box. However, you will be able to analyze the two ports by means of by testing with different input signals, um, and then you will be measuring the output signals. So by analyzing this and this how this two port is behaving for different inputs and outputs, you will be able to characterize, you will be able to define the some parameters like H parameters, you have Z parameters, you have Y parameters, you have then ABCD parameters that you will be going to learn in the electrical circuit analysis part. The same thing you are going to apply here. Okay, so all these electronic devices are basically non-linear devices. However, for a small signal equivalent circuits, we will be considering them as linear circuits. It's something like we are just approximating those non-linear circuits as linear circuits for small signal equivalent circuits. And then we'll be doing the analysis. And then we have something called biasing. So in the biasing, we'll be having different configurations again: fixed bias, collector feedback bias, emitter feedback bias. So you'll be learning what is biasing once you start with the diodes. So basically, biasing means giving some kind of voltage. So whether you're giving a positive voltage, if you're giving a kind of a positive voltage to the anode and negative voltage to the cathode, then it's called a forward bias. If you're giving the negative voltage to the anode and the positive voltage to the cathode, then it's called a reverse bias for a diode. Similarly, for a transistor, we have three terminals, right? So we have to give different signals for both at the input terminals and the output terminals. We'll be giving different voltages or the signals. Okay, based upon the configuration that we are giving, different configurations are they available. So we are learning about some of those configurations, how we are able to give the signals. That is called as transistor biasing. So we have 4 or 5 configurations are available. So we'll be learning the advantage and disadvantage in each of these configurations. That's about your uh, bipolar junction transistor. So and then you have something called JFET. So JFET, full form of JFET is junction field effect transistor. So you have basically the difference between a bipolar junction transistor and JFET is that your BJT is a current controlled device, and whereas JFET is a voltage controlled device. That's one of the major difference between a BJT and a JFET. Okay, so and then it's a unipolar device. JFET is a unipolar device, whereas BJT is a bipolar device. So unipolar or bipolar depends upon the what type of current carrying elements are there within the circuit. Okay, if the current is due to both the majority and minority carriers, then we call it bipolar. If the current is only due to a particular either majority or minority carriers alone, then we call it as a unipolar device. So in JFET, it's a unipolar device, and then we have it is controlled by the voltage signal, whereas BJT is mostly controlled by the current signal. Okay, so BJT is a current control device and JFET is a voltage control device. So we'll be comparing both the transistors. So we'll be comparing the BJT with the JFET, and then we'll be dealing about the construction, operation, characteristics. Similarly, how what we learn about BJT, similarly we'll be learning about JFET. Again, we have to learn about JFET biasing, and then we have to learn about feedback amplifiers. So while I'm talking to you, in between I'm asking you to reply, right, whether I'm able to reach you, whether my voice is reaching you or not. I'm asking you questions, right? So I'm taking some kind of feedback from you, right? If there is no proper feedback, what happens? I may be shouting here, but you may not be able to reach. I will not be knowing that, right? So there might be a large output. So So constantly we should have some kind of feedback when we are doing any kind of controlled process. See, in the control systems, you'll be learning more about the feedbacks. In the upcoming semesters, you may be learning about these control systems. But I can generally, with as a layman, I can say that for every process, you need a feedback so that the error will be minimized. Okay, so there are different type of feedback amplifiers are available. So some of the feedbacks may result in increased amplification. So your amplification or gain will be high, whereas stability will be low. And some of the kind of if you are giving, for example, positive feedback, in positive feedback may result in amplified gain and reduced stability. Negative feedback may result in reduced gain and increased stability. So there is some kind of advantage, some kind of disadvantages that will be dealing. So mostly most of systems will be having negative feedback only. Okay, even in your control systems, you will be learning about both positive and negative feedback. But you should have a common notion that you should always keep in mind that negative feedback systems are more stable than a positive feedback systems. Okay, so so you have something called BIBO stability, bounded input and bounded output. So if you're going to give a positive feedback continuously, you are going to the output will be increasing for every iteration and may result in unbounded output, which may reduce the stability. Okay, so I'll not talk much about it unless I'll start this topic, and then I'll move on to the next topic called op amps. So op amps is the shortcut for your abbreviation for your operational amplifier. Okay, so this operational amplifier is usually a IC or an integrated circuit in which there are some specific properties that you'll be seeing. So it works as amplifier. It is not a single transistor, it's an integrated circuit. Okay, so you'll be learning about the pin configuration. You'll be learning about different amplifying stages. There's a block diagram is available. So here you'll be learning about the amplifier stages and different parameters like how it works in a closed loop kind of configuration, how it works in a open loop kind of configuration you'll be learning. And then you'll be learning some of the linear applications, and then uh, something like adder, subtractor. So most of your digital circuits are working because we have something called op amp. So if you have some kind of calculations that you are doing, that is achievable because of this op amps only. So these are, so we have a number of standard op amps are available. These are ICs. I am reiterating that it is not a single transistor. It's a block of different components. Okay, it's an integrated circuit. And then we'll be learning about some nonlinear applications of op amp. And then there's something called 555 timer. So 555 is the name of the IC, and it's a timer circuit. So I think in most of the films, no, you might have come across something called time bomb, right? There should be some timer circuit for its operation. So if you want to start a countdown, even in the I can see that I can start a countdown if I want. You have something called countdown. So if you want to do some any kind of countdown, or if you want to go for any timed circuits, then you have to use a IC which is acting as a timer. So we'll be learning about the most common timer circuit that we will be using is 555 timer. So where 555 is the IC name. Okay, we'll be learning why the name is given 555. Okay, this is the most common timer circuit. And then you have a number of oscillators. So oscillator is nothing but a signal generator, I can say. The major difference is between oscillator and a signal generator is that signal generator may be giving a standard signal, something like a sinusoidal signal, whereas oscillator can be a sinusoidal signal, can produce a sinusoidal signal, may also produce a non-sinusoidal signal. So oscillator, by the word oscillator, you should know that it is oscillating, right? So these oscillators are basically signal generators. Okay, so we have some kind of oscillators like Colpitt's oscillator, Hartley oscillator, RC phase shift oscillator. So by using some of these analog components, so we'll be able to generate oscillators. So without any input, they should be able to give output. So what we are going to do is we are going to give a initially they will be given some kind of a signal, and the signal will be amplified forever. Okay, so even after removing the signal, so when the output is given as a feedback to the input, then what happens, the loop will continue and the signals are going to be generated forever. Okay, that's how that's a general principle of oscillator. We are going to give a feedback to the at the input terminals in the oscillator, and then we'll be learning about timers, functional diagrams, lock loop. So we'll be learning about these things, and then we have this application, specific applications of this ICs, like for voltage regulation we have a IC called IC723, and then you'll be learning about multi vibrators, monostable, stable. So the different kind of multi vibrators are there, and then you'll be learning about some standard wave generators like triangular wave generator, sawtooth wave generators, and then Smith trigger circuits. So and then you have your function generator. So function generator generates any signal. Okay, it may generate a sinusoidal signal, it may generate a non-sinusoidal signal. So you might have seen the function generators in our laboratories also. Okay, so we'll be seeing how we are going to work. And so it's amalgamation. So your subject is basically amalgamation of two different subjects. One is the basic electronic devices, other is the this integrated circuits. Okay, so we have two textbooks for this subject. First one is Milliman Hawkes, the standard textbook which deals with electronic devices and circuits. So for the first two units, for even for the third unit, half of your third unit, so for the unit 1, unit 2, and for unit 3 until feedback amplifiers, you have to refer to this Milliman Hawkes textbook. So either you can take from the library, or I have the soft copy of this textbook. I'll be sharing this textbook with you. And then for the remaining half, so from this op amps, from the topic of op amps till the last topic, you have to refer to this textbook called Linear Op Amps and Linear Integrated Circuits by Ramakant Gaikwad. This textbook is not available in the as a ebook format. So as soon as if I get any kind of soft copy, I will be sharing this with you. However, these books are available in any market. Okay, any a shop that sells engineering books. This book is very famous, Ramakant Gaikwad, because most of the ECE and EEE people will be reading this textbook. Okay. So besides this, you may refer some microelectronic textbook, TMH publishers, or Maheshwari Analog Electronics, or Salivahana. So these two are the textbooks given to you are your standard textbooks. So I always suggest you to go through the standard textbooks. Okay. And then your syllabus will be divided into 12 cluster groups. So each unit is divided into two cluster groups, CG1, CG2, and basically you have 6 clusters. You have 5 units and 6 clusters. So you'll be getting the questions from each of these cluster groups. Okay, so from each unit, so a lot of say 20 questions or 30 questions will be prepared. Okay, so you can expect question from each of these topics. So question so will be prepared such that all these topics are covered. Okay, so you will get a question from on structure and operation or diode equation, VI characteristics. So basically it's the same as a syllabus, but in detail it is given such that you will be knowing about what type of what topics will be asked in your examination. Okay, you can refer these things. So with this, I'll end about this subject as a introduction. I will be closing this. Now I'll be dealing you with something called canvas. So did Gauri Shankar sir introduce you regarding canvas, or did he not introduce? Please let me know.
No, sir, not yet, sir.
No, sir.
No, sir.
No. Okay. So
Yes.
canvas is a LMS. So LMS means stands for Learning Management System. So we have different LMSs available. So something like you might have heard about Blackboard. You might have heard about Moodle. So I'll be showing you two LMSs today. So one is called MVGR Moodle. Okay. So basically what we'll be doing is that I think some of you have already joined some courses like Coursera, right? In Coursera, you might have seen that the contents of the Coursera are basically something like they will be divided into different clusters or modules, in which in each module they will be giving you some video lectures, they will be giving you some kind of PPTs or materials, and then they will be giving you some kind of assignments or some kind of quizzes they will be posting. So very similar to that, we have this LMS called Moodle. Okay, so this is hosted by MBJR. Of course, as of now, the access is only with the admin access with only with the CSC people. I do not have the access. Only one small temporary module was created for teachers. Okay. However, I have my own module called Canvas. So I'll be showing you that. So this called Canvas is another learning module in which I can create my course for free, and I can add the students to my course. So I have 4 courses in my dashboard. You can see that. So this online teaching is a course in which I was enrolled as a student, and these are 3 courses I am hosting right now, and this is our analog electronic course. So this course is not fully developed as of now, so I will be showing one more course in which I can show you how you can use this. So I'm currently teaching a subject called MATLAB to IT students. So I'll be showing the advantages of having LMS. So basically we have 2 modes of learning. One is called synchronous mode of learning, other is asynchronous mode of learning. So in synchronous mode of learning, you will be learning through the live classes. So what I'm teaching right now is a synchronous mode of teaching. So you'll be listening to the class. You'll be jotting down some kind of running notes and all those things. Whereas asynchronous mode is we can learn at leisure. So you can check the materials, you can do the assignments at a leisure hours apart from your class. So then we have something called blended mode of learning. So I'm going to prefer this blended mode of learning where I'll be directly interacting with you in the live classes, and then I will be sharing you the material, all those things, or I will be giving you some kind of assignments or maybe conducting some kind of quizzes, and there's a canvas module. Okay, so you can see that on opening this, I have some recent announcements. I have a course description, objectives, course outcomes, a list of instructors. So this all pages created by me. So and then if you go to the people tab, I could enroll almost 300 plus students. So spread across four sections: CSE 2 sections, IT 1 section, and then civil engineering. Okay, similarly, what I'll be doing is for the analog electronics course also, I'll be inviting you to this canvas where you'll be having contents of your course. So in this tab called modules, you'll be seeing your course contents. So you have 6 modules, right? So you have 6 clusters, right? So I'll be hosting 7 modules, beginning with module 0 till module 7. In module 0, all your basic information like course information sheet, lesson plan, timetables, or some kind of introductory videos, like any prerequisites are there. For example, if you want to learn about this EDC, you require the prerequisite of semiconductor physics. Okay, I will be testing that soon in this class itself, and then I'll be giving some kind of videos. So I have a video like how to use Canvas. So if this I'll be sharing in the WhatsApp group. I'll be embedding the videos. So this is a video, and then PPTs also I can host on the Canvas. So it's something like at one place you will be seeing all your course content. Okay. So I will be embedding your PPTs. Even I can give you assignments also. I'll be showing the assignments too. I can give you can have a discussion. Like, for example, I have initially given an introduce yourself discussion for the students. It's a great, I can make a discussion, a great discussion if I would like to have, or a non-grade discussion. So here people will be answering. So I can, here almost 179 people have answered to this discussion. So if you have any kind of doubts, you can post your doubts in the discussion threads. I have not fully created the course for analog electronics. It is still in the pipeline. This is for MATLAB that I am showing. Similarly, I have hosted some basic content for analog electronics also. So in the discussion thread, like in NPTEL, you have discussion thread for each and every unit I will be creating. So either you can post your doubts or you can clear the doubts of your classmates. I'll be also be posting some recorded videos of your classes in the discussion threads itself. I can also post attendance report. I can get a feedback. Okay. And also you can see the grades also. I hosted some quizzes. In a grade book. So if it's a quiz, it will be auto graded. If it's some kind of a manual assignment, I have to manually grade those things. Okay. So I can give timed quizzes. I can give with multiple attempts, like in Canvas. Sorry, like in Coursera, you might have come across some multiple attempts, right? So I can give you enable multiple attempts for you if you like to have. I can create a question bank from which random questions will be generated for you. So this is convenient both for the faculty and for the students. Initially, you might have some kind of hiccups. So what I'll be doing is I'll be sharing you a video regarding this Canvas, how to sign up, how to log in, how to join a course, and all those things. I'll be sharing in the WhatsApp group. And also I think I have given you a Google form link, right, in the WhatsApp group. So please fill the Google form, because I need to know all these basic details like your email addresses, your roll numbers, and your phone numbers in order to join you into the course. Okay. So I'll be showing the course for you on analog electronics. So once you join the analog electronics course, I have given some prerequisite videos. So I have made a prerequisite video. I think in your physics, this semiconductor physics is covered for you in your first year, or is it not covered for you? Topics on semiconductor physics.
Yes, sir. Completed, sir.
Completed, right? So this is a prerequisite module. So I have given a video lecture on semiconductor physics. A PPT and a handwritten notes is also embedded. I also hosted some small quiz. So I'm embedding the handwritten notes also. Okay, so whatever is available with me, I will be sharing you all those contents within this Canvas module. Okay, and you will be getting the announcements. From the announcement, if there are any kind of changes, you should be getting it from the announcements page. So when I announce something here, you will be getting a notification for your mail also automatically. Okay. So initially the name of the subject was electronic device circuits when I actually created the course in July. Recently, I think the entire syllabus was changed. So, okay. So I even during the class hours, what I'll be doing is, in order to ensure that everybody is active in the class, what I will be doing is I will be randomly calling some people. Okay. So I have created a random picker. So of course it's not because of Canvas. I have used some third-party website and then embedded the same content over here. For example, you can see for a section, I think the page is loading. I'll be spinning this wheel and some random person from the say section will be selected. So that person has to answer me. If I am asking some question in the class, that person has to answer me. Okay. So let me spin this for a while. So I think roll number 12, Ganesh is selected. So I'm just showing a preview. Okay. Similarly for B section, I've created under spin. So I'll be calling both the A section and B section people. I'll be spinning this. I'll be randomly calling you people. Okay. And then I'll end this class. So I may take 10 more minutes because my class started at 12 for 11 for 12:40. So I'll be giving a small quiz for you. I'll be giving a link in the very small quiz. I think even those who have some basic knowledge on semiconductor physics should be able to answer. Okay, so I'll be posting the link in the chat box. I'll be sharing my screen also. So you should answer. So before answering, so when it asks to enter your name, please enter your roll number. Okay, so do not enter any kind of uh, anonymous names. Okay, so it's a small playful quiz. You can also get some kind of memes in between or some kind of peppy music also. I always just want to engage you people. Okay, so I have posted this quiz. Can you see? Did you get the quiz link?
Yes, sir.
Yes, right. So please answer. I'll be opening the quiz over here. I'll be starting this quiz. No players. Okay. No players currently. Okay. So join this quiz. You can enroll. You can write your names. It's a very small quiz. It not long, much than 5 to 10 minutes max. A simple quiz.
So shall we enter our names or
No,
roll
no. Sure.
numbers?
Enter your roll numbers. Enter your no roll numbers. Roll numbers is better because two people might be having the same name, right? So to avoid that, always write your roll numbers. So I'll be getting the number if you are enrolling yourself. I'll be getting the number. Still the number is in 0. Okay. So I just want to have a small assessment of how you, so at what level you are there, so based upon which I should schedule my classes. Did you get the link or not?
Yes, sir.
Yes. So enter your roll numbers. Did you enter your roll numbers?
Yes, sir.
I do not know why I have not yet got this. You can turn off the music. You can turn off the music, okay? I'll just check. So what is the number you are seeing over there? I do not know why I am unable to see that same quiz. What is the number you are seeing? Okay, one people have joined the quiz right now. I do not know why on the others I am unable to see. So in case you have joined a different quiz, just I will be reposting the quiz link. Maybe I think the URL might have changed. I have created this quiz yesterday. I'll posting the URL now. Actually, my laptop is a little slow, and that's why I have to keep everything in my mobile, and then I'm sharing with you guys. So I'll be sharing the link with you. So I think the new link, so new link, okay. Do not go with the old link. So please delete, please forget about this old link, and just try with this new link. So I post this new link. Yes. In every class, I'll try to post some kind of simple quizzes or some kind of games. I'll try to introduce so that you'll not get bored during the classes. So do not think that these are for actual marks. I just want to have some kind of a simple interaction with you. That's it. So 45, 47 people have joined. Okay. I'll be starting this quiz so that I think you have other class also. So I do not want to wait. So you can start your quiz. You can play. I will turn the music. If 48 is at the top. So 48, 81 are leading. Now 59 has taken over 48. 81, B section 81 is in the third place. So from next class onwards, please be in time. So I'll not take the attendance for those who are joining after 10 minutes. So I'll be giving 10 minutes of grace time. So you should join before this 10 minutes of grace time. Okay. If you are unable to join the class on any particular day for some reason, you should pre-intimate me. Okay. '59 is at the top, followed by 42, and then followed by 44. I think all the B section students are lagging behind them, A section students. I could see only 263 at fifth position from B section. All others, I think, mostly are A section. 234 has come up to the second position. Okay, I'll be sharing you the leadership board, final leadership board at the in your WhatsApp group. So now I'm ending this class now. So before I end the class, I'll be taking the attendance and then I'll be taking.